Hi guys, welcome back to my channel. Today's project is to generate your own QR code on the Flutter app and display it on 1.5-inch screen via Bluetooth Serial. This kind of solution can be very useful in your life. Let's find out how we can get an image from ESP32 over Bluetooth. Let's get it. The point of today's project is to complete the image file in ESP32. The Flutter app creates a QR code and transmits the QR code image to ESP32. ESP32 combines multiple bytes, which is image data, to write a file to SPI flash file system and showing it on the display, which has 128 pixel by 128 pixel resolution. It's a simple system. First, we do the wiring for SSD1351. I'm using hardware SPI to draw the screen quickly. For this, you need to find out your ESP32's pinout from MOSI, which is master out, slave in, and SCRK, which is a serial clock. The other pins don't matter where it is. Open your Arduino IDE or your preferred IDE to make a new project. To use SSD1351, we need the graphic driver. I will use the Adafruit library. If you don't have it, please install it. Include the Adafruit SSD1351 header file and SPI header file too. Define basic information, the screen size, pinouts, and white color code. You don't need to have any color code here. In my case, I want to see the white screen after it's up and running. When creating a TFT in the code, you don't need the MOSI and clock pin because it refers directly to SPI. Let's initialize the TFT and fill the screen with white and run it. Build, up and running. You can see a white screen with nothing. Let's continue to add functions based on this. This time, add the Bluetooth library. This part is the same as before, so I think you're very familiar with it. Start serial bit with the device name. This name is shown when it's searched on another device. If there is a problem, restart ESP32. It's a function that registers the most important callback function in the Bluetooth part. I'll make the callback function in a moment. This concludes the Bluetooth initialization. The Bluetooth callback function has two parameters. One is for the type of the event, the another one is for data. So you can figure out the data based on the type of the event. For example, you can get the MAC address of the connected client if it occurs a server open event. When data event occurs, it means there is incoming data from the connected client. Since the second parameter has not only byte data but also the length of data, so we can use it in what we want. This is a little bit of a tricky part. The Flutter app splits the image data into byte and sends it. The problem here is we don't know when the data transfer ends. So the way I do this is before the app sends the image, I send the dummy data, which is one length. After the image transferred, it also sends dummy data of one length to inform the end of the data. If you look at the app section, you will definitely understand what I do. When data of one length comes in, the bool variable is writing is checked to determine whether to open or close the file. After taking action for file, it's changing the status of is writing. For example, it's going to be true to false or false to true. For data that is not one length, simply continue to write to the file. You can write files from the streaming data like this. I almost forgot to add the SPI flash file system header file. The part of the file system is not done yet, but let's build and see the console. It should be ready to use Bluetooth first. Yes, it says now I can pair it with Bluetooth. Let's complete the SPI flash file system now. SPIFFS must be initialized to write or load files. Enable the SPI file system through SPIFFS.begin. I'm gonna format the SPI file system to clean up. This is done only once at the beginning. Let me add one function so that you can see a list of files in the file system. In the example of Tiny JPEG Decoder by Bodmer, the function to view the file list is well implemented, so I'm gonna use this. The link is in the description below. If you don't need to check the file list in the SPI file system, it's not necessary. Let's add init SPIFFS function in setup. Okay, let's build this and see if it's working or not. Bluetooth is initialized, SPIFFS format is started, formatting is always taking the time. The format ended successfully. I checked that there is nothing in the current file list. From now on, let's complete the part where the JPEG data received from the app is displayed on the screen. To display the image on the screen, the first thing to do is checking the existence of the file. If there's a file, I will draw it on the TFT screen using the drawFSJPG function. The parameters of this function requires the starting coordinates of the screen. Since the app sends the same image as the SSD1351 screen size, I will go with 0,0. To use the drawFSJPG feature, you must add the JPEGDECODER library first. Second, you must bring the function prototype of the drawFSJPG. The links are described below. Copy and paste the entire contents of this file. We generally use JPG easily, but it's not easy in embedded system due to the various restrictions. Anyway, you can use this feature to display JPG on SSD1351. Go back to setup and call load JPG file function. The reason I do this is to display the existing file even if the system restarts. Go to the end of the writing file. Let's also call load JPG file function here to display the newly received image on the screen. Remove the code for formatting before building and uploading the source code. This is all about ESP32 coding. Let's go to Flutter and make an app. The app we are going to create today has the same basic part as the previous project, so I will proceed based on the existing project source code. It's going to save time a lot. The link is in the description below. First, I will make a new Flutter project. Add a library for Bluetooth Serial. I copy and paste the source code of the previous project. I'm copying the main.dot file of the previous code to my project. Of course, errors occur because there are no other files. Let's bring the Bluetooth device list entry file and the detail page file into the current project. I brought all the source codes from the previous project. The file path does not correct because the project name is different. After erasing the file path and then importing again, there is no problem. As you know, in the previous project, we received the image from ESP32 cam and shown it on the mobile screen. I'm gonna remove everything not needed for today's project and make it clean first. Okay, all errors gone. I try to organize it a bit more. This part that sends the data will be modified later. Comment out to the nothing temporary. We don't receive any data from ESP32 on this project, so we have nothing to do with the onDataReceived function. It also removes any variables that have stored the byte data. Finally, we are late for today's project. If you need an explanation of this code, please refer to the previous project. Before building for Android, we need to set the minimum SDK to 18. This is required for the Flutter Bluetooth Serial library. Let's build and see what it looks like on the real device. There's no work has been added, so we can only connect the Bluetooth device. When the app runs for the first time, the permission of the device location is required. Select Allow all the time if you keep a connection in the background, or allow only while using the app if you want the app to be able to connect only when it's in the foreground. Touch the setting button to search for and connect Bluetooth devices. It found my ESP32, which is QR display 1, selected it to pair. After pairing, press the back button to return to the app. A list of currently paired devices is shown on the screen. Select the device from the list to connect it. Once connected, there is only one button on the screen. You can also check the Arduino serial monitor to see a string indicating that the client is connected. Let's make it possible to generate a QR code on the screen. There is a great Flutter library to generate a QR code with the string you want. Let's add it to our project. Create a string variable to set the default QR message. I will make a pop-up to change this string later. Create a global key. The reason is that we can access a specific widget with this key. Go to the scaffold body and recreate UI. Use the expanded widget so the part where you write the QR code is the main part of the screen. The repaint boundary is a widget that creates a separate display list for each child. It's use capture screen of the child widget. Use the pre-made global key here. With Custom Painter, Flutter gives you access to row-level graphics painting. Best of all, painting in the Flutter is fast and efficient. Since the QR library we are going to use is made of the Custom Painter, we have to use it like this. The size of QR code is 128 pixels. It makes the same screen size as SSD1351. QR library has lots of options. The contents of the QR code use a pre-made QR message string. The version of the QR code range from version 1 to 40. Each version has a different module configuration or number of modules. No specific version is required, so let's do it with auto mode. It allows you to specify the color of the QR code. Set the QR code color to black and blank space to white. The current background color is black, so it changed to white. Add a text widget to show the current QR content. Let's build it and see what we have done so far. As shown on the screen, the QR code was generated. Let's create a part that transmits this QR code to ESP32 via Bluetooth Serial. Only JPEG type is allowed to display the image on the screen of SSD1351 of ESP32 since the JPEG decoder is used. Also, officially the repaint boundary does not support JPEG output, so we must first capture QR code with PNG and then convert it with JPG. A library called image has many features related to image processing. I will use this. First, I will change the button's text to send to ESP32. When this button is pressed, make sure that a function capture QR is called. Let's make the image from the QR code on the screen. Use the global key to find the specific widget that is displayed on the screen. The type of the boundary is render repaint boundary. As you know, Dart UI has a default image type, so use the image as the abbreviation of the image to avoid duplication. Also use UI for Dart UI. Extract a UI image from the boundary. After that, convert the UI image with PNG format and save as byte data. The PNG bytes has encoded byte data. Now we need to convert the UI image to the image type, which is from the image library. Decoding the encoded PNG byte into the image type first. The decoded PNG image is encoded in JPEG finally. After all process, pass it on to the sendByte function. Let's modify the sendByte function. From the captureQR function, we got the byte data from the QR image. What I have to do here is to send the image to the connected Bluetooth device. What we need to do before sending an image is to send data with a meaningless length of 1. If we quickly send the following data, the data will be combined and sent. To avoid this problem, I'm gonna make a 1 second delay on purpose. To let it know the transmission is complete, I send the data with a length of 1 again. That's it. Let me take a look at my code to check whether there is an error or not before building this app. All looks good. Let's build and try to send QR code to ESP32. It's up and running. I just pressed the send to the ESP32 button. My ESP32 gets the data which is 1 length. It's opening file because this is a first time data. Now it's writing JPEG file with the byte data via Bluetooth Serial. Finally, there is a data which is 1 length again, so it's closing the file. The list of files is shown. The QR code JPEG file has been created. Let's see the display. The QR code is showing normally. This QR code will be kept after rebooting the ESP32. Let's add a simple pop-up dialog so that you can modify the contents of the QR code in the app. I'm gonna create a text editing controller to receive input from the user. Also, I'm creating a function called editing dialog to make it easy to pop up. Simply create an alert dialog and add a text field in the content to receive user input. I don't know why I put here the hint text, no longer than 80 characters, but you can put longer than this. Make a done button in the alert dialog. If it pressed, close the pop-up, update the QR message string with new one, and redraw the screen. That's all for the dialog feature. Go back to the scaffold and add the actions, editing the flat button to execute the editing dialog I just made. Let's build. Oops, I missed adding semicolons there in the editing dialog. Okay, let's try to build again. Press the edit button on the top right of the screen. A dialog pop-up appears allowing you to enter text. Type any text you want. Press the done button and see the QR image has changed based on the new text. Let's test if the QR code is actually read on mobile. I'm using the Lens app by Google. Unfortunately, it's hard to read on mobile. The reason why the recognition rate is so low is that probably the speed of the camera and the screen drawing speed of SSD1351 are so different. The easiest way to increase recognition is to reverse the color. Let me show you how we can handle it. Go back to the QR painter. Let's change the colors. The primary color is white, and I will use black for the empty color. And I will make the QR code with longer text for the test. Okay, let's try to build again. A more complex QR code has been created. Press the button and send to ESP32. My ESP32 got the new QR code now. Let's try to read it again. Mobile can read it well this time. It seems like Google Lens parses only URL by default. Also, the square shape of the QR code is well separated. The feature of the Google Lens is really awesome. Also, I checked my iPhone reads it well. How was today's project? I hope you liked this project. Thanks for watching. See you in the next video.